Right, got a bit of core further maths here. Demoivre's theorem. Here's Abraham Demoivre, lovely painting by Jean-Paul Demoivre, age 34, and here's one by his daughter, Josephine Demoivre, age 8, not so good. Yeah, did great things. Demoivre, most notably, of course, his famous theorem, cos theta plus I sine theta to the power of n. Stick the n's down with the thetas, cos n theta plus I sine theta. One of the most beautiful things in mathematics, I think. Yeah, did a Frenchman who did great things, like the French rugby team.
Before, where they go one end to the other, and they're looking to do it again. Ramos Dupont, and with the line at his mercy. Before, Moefana pulls it back. Jalabert, little gap acceleration. Peno knocks it forward, and George, no better exponent at the back of that maul. Mitchell takes it. Back it goes, through the centre, Daly goes, Daly! All day long, it's a try!
Anyway, so here's Demoivre's question. It says, use Demoivre's theorem to show that sine 5 theta is a sine 5 theta plus b sine 3 theta plus c sine theta. We're going to find out what a, b and c are. So we're changing a power into signs of multiples. You've also got to go the other way, where we've got the cos or the sine of a multiple into those powers. The way you do that, we use Demoivre's theorem with the 6. And then I'd use the cis notation, C for cos theta, S for sine theta. So we'll write cis of 6 theta is C plus IS to the power of 6. You can write cis to the power of 6, but then we can use the binomial expansion on the right hand side. So I have c to the power of 6, and then 6 c to the 5 is. But we just want the real part, because 6 theta is just the real part of the right hand side. So if I want just cos 6 theta, I'll get rid of all the imaginary parts. 6 c to the 5 is, that's imaginary. All the odd powers of I are going to be imaginary, so we can get rid of all those. Use the fact that I squared is minus 1, I to the 4 is 1, I to the 6 is minus 1, and it looks like that. And then we use sine squared is 1 minus cos squared to get it in terms of coses. But we've got to go the other way, and the way we do it is this. We write z is cos theta plus I sine theta, and if you do 1 over z, that's cos theta plus I sine theta minus 1. So we can use Demoivre's theorem, put the minus 1 in with the thetas, but cos theta and cos minus theta are the same. But sine minus theta is minus the sine of theta. And if I write them out like this, if I add them, I'll get 2 cos theta, get rid of the I signs. But if I subtract the bottom from the top, it'll get rid of the coses. I'll just have sine thetas, but I'll have plus 2i sine theta. I can do it with any power, of course. I can do it to the power of 5. Again, subtracting, I'll get 2i sine 5 theta. That's really what I'm going to be using, because I want sine at the power of 5. So what I'm going to do, I'm going to raise both sides to the power of 5. So the left hand side will be 32i to the 5 sine at the 5 theta. The right hand side, I'll do the binomial expansion, start with z to the power of 5. I'll have 5 z to the 4 minus 1 over z to the power of 1, and do the binomial expansion on the whole thing. Then do a bit of simplifying. Z to the power of 5 minus 5z cubed, 10z, and so on. I'll group the terms that I want. So I want the z to the power of 5 and the z 1 over z to the power of 5 together, because that gives me 2i sine 5 theta. And it's starting to look like the right hand side now. I've grouped together the z cubed and minus 1 over z cubed, and the z and minus 1 over z, like this. Then z cubed minus 1 over z cubed is 2i sine 3 theta, and z minus 1 over z is 2i sine theta. So what I can do with that right hand side, I can take a 2i out as a factor, because then I can sort of cancel out the I and the I at the power of 5. Divide both sides by 2. So the sine at the power of 5 is 1 over 16 sine at the 5 theta minus 5 sine 3 theta. So the A in the original question is just a 16th, the B is minus 5 over 16, and the C is 10 over 16 or 5 over 8. But I'm going to leave it like that for now because I want to do the integration in the second part. So if I want to integrate sine at the power of 5, I'm going to change it into the sine 5 theta, sine 3 theta form, because I can integrate those. So when I do the integration, I'll need to differentiate cos 5 theta to get sine 5 theta, but I need to stick a minus a fifth in front to get integrate sine 3 theta. It's going to be cos 3 theta, but I'll need a minus a fifth, the third in front. So I actually have plus 5 over 3, and then the 10 sine theta minus cos theta gives you sine theta, so I need a 10 in front to get 10 sine theta. Then I'll use the fact that cos of pi over 3 is a half, 60 degrees really. Cos of pi minus 1, cos of 5 pi over 3 is a half. And I also need cos of 0 for when I sub in 0, and that's equal to 1. Subbing all those in, I'll have a 16th on the outside, but I'll have minus a fifth times a half, 5 thirds times minus 1, and minus 10 times a half. Then when I put 0 in, well, cos of 0 is just 1, so it's just minus a fifth plus 5 thirds minus 10. And then I can stick that in a calculator then and subtract and get 53 over 480.